Hi everyone, in this video we will see how we can clean our tips and in general tip cleaning strategies. So whenever we are using the NanoFrazor, as we are sublimating polymer like PTA, or we can also use other materials, but in general we have a lot of possible contaminants in our complex thermochemical and mechanical system that can cause contaminations. Of course, the tip can also be slightly damaged once we do the lithography step. In that case, we don't really have contamination, but a blunting of the tip. But when we see both of these effects, either blunting or contamination, we're able to see them on the approach curve, because the adhesion length in case of contamination usually increases together with the tip height estimate. So when we see sharp increases, especially in the tip height estimate, like in this case, for example, we are probably picking up some contaminations, even if it's not so sharp, but we see a continuous increase in the tip height estimate. This is a typical indicator that our tip may be getting contaminated. So how can we clean the tip? I will say there are three main approaches that I usually adopt. And one thing that it's important to mention is that these approaches are not 100% success guaranteed. So these are approaches that I usually try sequentially if I want to try to clean my tip. But again, it's not 100% success rate strategy. So let's see the first one. The first one is based on the approach. So first we have to perform an approach to basically know what is the distance of the tip between the tip and the substrate. Why? Because basically we want to gently tap into the surface. So in this situation, specifically, we are around 12 or 18.94 microns away from the surface. So we want to gently tap the cantilever inside in the surface and then move it around a little bit. So we can maybe move it down by a distance that's a little bit larger than 12 microns. So we can put maybe 13 micron or 12.5, and then we move along the Z direction down. So if I move by 13, this means that I will be basically pressing the tip in the PPA layer. And this will also be visible because the cantilever will be slightly bent, and the reflection of light will be changed. So let's see. Basically, you see now that the cantilever slightly changed its inclination, so it looks optically a little bit different. So now what do? Now we are basically a little bit inside the surface. Of course, the polymer is much softer than the silicon, so this should not create big damages to our tip. And then we move around by a small distance, let's say 5 micron, on different directions. Basically, we are dragging the tip across X, Y, maybe diagonally. We can move up and down, make a small path. Okay, this will be enough. Like basically I move the tip down and then move it on X and Y. Now I can lift it up. Okay, and it's done already. So this will be the first approach that I could recommend you. And usually, in order to see if there is a contamination, if there is help in cleaning some contamination, what you should do is another approach curve. And if you see a decrease in the tip height, this means that this helped. In this case, the tip didn't show specific contamination. Still, we see a decrease because we had from 1350, now we are 1310. So it's possible that we actually also clean the tip a little bit now as well, but I was not sure whether the tip was contaminated. I'm just trying to show you the strategies that you can adopt. So this is strategy number one. Strategy number two consists into heating up the tip. So in this case, to achieve a higher temperature on the tip, we want to move a little bit away from the surface. Maybe we can lift up the cantilever by 200 microns. Why do we want to lift up by 200 microns? Because if we're farther away from the surface, then we have more air that acts as an insulating material around our tip and our cantilever. So the temperature on the tip will be closer to the temperature that we set on the heater of the writer. So the idea is that we want to heat up the tip to a high temperature so that maybe this temperature can help us sublimating or removing some contaminants. So how do we do that? Well, we have to know which voltage we need to achieve a specific temperature. So I run an IV calibration after I lift up the cantilever. Okay, so let's say I want to heat up to a quite high temperature, maybe 1300. So I need 8 volts to reach this temperature at this specific height I am at now. I will not recommend to heat up to extreme temperatures like 1400, even 1300 is very high, so don't leave the cantilever at this temperature for a very long time because such high temperature can cause damages if applied for too long. So we have to basically turn on manually the heater of the writer applying this voltage. So we go into utilities, we go to the DAC panel, and in the writer voltage we write 8.0. We press play, and now the temperature is still not applied. The voltage is still not applied. We need to turn on the switch. I also want to show you that we are indeed doing this. So how can we see it? Basically, I focus on the cantilever now. And if I'm applying a certain voltage that causes such a high temperature in the writer, then I should be able to see it optically if I turn off the lights of the microscope. So I can turn them off here. And then I go again here into the switches and I turn on the writer. As soon as I turn on the writer, we should be able to see. Here we see it well. First of all, where the writer is located, and also that the area is glowing because it's at 1300 Celsius. We can leave it on for a few seconds and then turn it off. We can also check that if we decrease the voltage, let's say put 7, then the glowing will be not so strong. See, now we see it milder because the temperature is lower on the heater of the writer. So that's good enough. So after you've done this, it's another suggested way that you can adopt to clean your tip. Now we turn on the light of the microscope. We perform another approach. And by performing this approach, we should be able to see if the procedure helped or not removing contaminants. Again, I'm just doing this procedure sequentially. So if there were some contamination, I may have cleaned them already. So we may not be able to see much from this tip height estimate change now. So it's going to take a few seconds more to perform this approach. We're almost there. Okay, we see that now we have another change into the tip height, another decrease, or maybe we need to clean even more the tip. So yeah, this is procedure, I would say, number 2. Procedure or method number 3 that we often recommend is to perform a grayscale pattern, because by patterning, especially with quite high force and temperature, we may be able to clean our tips. So let's import a sine wave. We can increase even more the depth. We say we put 30 minimum depth, and maximum depth we put 65. Let's go 65. Go 65. Then we add this to the layout. Go into the session, the warm-up. We'll place our design here. And we can maybe set a temperature that's higher than usual, maybe 1150. In this case, we may need Kalman feedback. And we can set an initial writing force of, say, 5, 2, 3. This is just a force that I'm setting manually. And we can use standard settings. I will press play. And again, the idea is that by patterning at different depth with different force and quite sustained temperature, we may be able to clean our tip. And we also need to keep in mind that when we pattern, we can also manually change the temperature. So let's say we want to increase it or decrease it as something that can be done. So here our pattern definitely much deeper than expected. Oh. The feedback is probably struggling. Actually, the force is the same, so I didn't realize this, but it's better. Maybe put another value, so maybe 2, like 5 here. One thousand 150 is also quite high, so let's put 1000. 1050. Let's increase this to minus. Okay. So you can choose a sine wave or any other 3D or grayscale geometry to try to clean your tip. I would say another possible approach that you can adopt is that of using step 1 and 2 together, which means basically gently tapping the tip inside the surface, but also heating up the tip while doing that. I will say not the best preferred way because you also need to be careful about the voltage that you set to heat up the heater, but it's also another option. But I would say as a bonus suggestion, you can use that. Here we see that the tip was probably a little bit damaged, so we're struggling to write well. And here probably we're cleaning it a little bit better. So now situation is a little bit more stable. But yeah, we can see that by just this simple writing, we can have positive benefits on tip cleaning. So just to sum up, in the end, we have seen 3 approaches. Approach 1 is gently tapping tip into the surface. Approach 2 is heating up the tip in air. Approach 3 is writing with the grayscale. I mentioned a bonus approach is combining approach 1 and 2, but requires a little bit of mastery, and it's not my preferred method. One thing that we should always keep in mind when we do tip cleaning, as we're using force and high temperature, and we may also do some gentle or not so gentle tapping into the surface, this can cause some blunting of the tip. So it's something that you should keep in mind. Once performing this operation, maybe the sharpness of the tip may be reduced. So if you're looking for very high resolution processes, I would really assess the situation of and the quality of the tip after doing this before continuing patterning high resolution, because the tip may still be good, but not good enough for patterning in high resolution. I hope this was helpful and could help you in using better and longer your tips.